In this lesson, we will discuss the project schedule network diagram technique. This technique is used as a foundation for schedule design, schedule analysis, and a lot of other techniques such as critical path method. We will be going into depth into all these other topics in upcoming lessons, so it is very important that you understand this lesson very well. The schedule network diagram is a graphical representation of activities and their logical relationships. On the screen, you can see the actual network diagram for our ongoing Hospital EHR project. This is a simplified view of the network diagram. I can elide as much data as I want here. Here you can see the same diagram with a lot more of the activity details, but it will be quite big. So what I have done is I have elided the data to show just the nodes and their relationships. Every relation is also labeled with the type of dependency. Here you can see FS, SS, FF. Okay. Of course, FS relationship will make about 85-90% of everything. The activities are represented by rectangles. The dependencies are represented by the arrows linking the activities. The start node and the finish node are mandatory, and I have used milestones to represent them. They are in this unique shape. The activities are like rectangles. Network diagrams can be created manually or using software tools. Network diagrams can include full project details, or they can have only work packages like we have, or some combination of both. Remember work packages from the lesson on WBS. The Microsoft project terminology for work packages is a summary task. If your project is complicated enough to justify network analysis, then you should describe the basic approach taken to sequence the activities. For example, why have I chosen SS here, why FF is chosen here, and so on. Every major sequencing decision should be compulsorily documented, ideally within the tool that you use. In our Microsoft project, you can double-click on any of this and add notes to any task, detailing why you have taken a certain sequencing decision. Any unusual sequences should be 100% fully described. This is because at a much later point of time, you will not be able to justify the reasoning behind choosing certain sequencing decisions. Modern tools such as Microsoft Project allow you to automate every aspect of creating a network diagram. In fact, I have actually created this diagram by starting with a high-level Gantt chart that you see here. This is the Gantt chart. This is the activity list. And then switching views to go to the network diagram. I will go to and fro between these multiple views until the schedule is perfected. Once the basic design is satisfactory, then the activity list is further broken down with the smaller and smaller tasks. This is the way of creating a schedule that is prevalent in the industry today. We don't sit down with large sheets of blueprint paper and manually create this anymore. It's all done using software tools. The entire process is repeated again until we reach the desired granularity. Okay, so what is special about this network diagram? The first point is the longest path in this network diagram from the start to the finish is called as the critical path. It's very special because one, it will tell you the duration of the entire project. Microsoft Project is based upon this same critical path methodology algorithms. The second point is that there are two special types of nodes that you have to pay special attention to: convergence path nodes and divergence path nodes. Notice node 2 here. This is a divergence node because it has multiple successors. It is a risky node because any delay on this one activity can impact multiple different activities. It needs a special protection by the project manager. Similarly, look at node 22. This is a convergence node. Very aptly, it is go live preparation. This is a convergence node because it has got multiple different predecessors. Now, this node is also very risky because it can be impacted by several other activities. Very logical. Your go live can be impacted by all the predecessors. Okay, and with that, I will conclude this lesson. This has only been a brief introduction to network diagrams. Schedules are essentially analyzed as networks, that is a part of the mathematical graph theory. But please do not be alarmed by the math involved because I promise to make it super simple. Moreover, the use of modern software tools will mean that you never have to do any of this math manually. Another good news is that the PMP exam no longer has math questions for this analysis like it used to in the earlier versions. But you should have a solid grip on the logic that is involved, and we will cover everything in simple examples. We will do that in the upcoming sections. From the very next lesson onwards, however, we will be moving on to estimation techniques. This is another of our project managerial super skills. A lot of estimation techniques will be discussed, so I will see you there next.